All right, let's set the scene. You're an RF tech out in the field, and suddenly a critical system goes completely dark. Now, your first thought is this just a simple hardware failure, or are we dealing with something a little more deliberate? Knowing how to tell the difference is an absolutely crucial skill. So today, we're going to break down exactly how to distinguish intentional radio jamming from all the other noise and failures you run into.
Now, before we really dive in, just a quick but really important note. What you're about to see is part 8 of a big 20-part tutorial. It's all based on a comprehensive report called An Introduction to Radio Jamming and How to Identify It, which is put together by RFI detectives. And just to be super clear, this is all for educational and interference mitigation purposes. It's designed to help you, the technician, identify, locate, and report illegal signals. And remember, using jamming equipment is illegal in most parts of the world, and yet often comes with some pretty significant penalties.
So yeah, the framework we're about to walk through comes straight from a technical report by the pros over at RFI Detectives, who are part of Virtualization Options LLC. This isn't just theory. This is the kind of practical, in-the-weeds knowledge used by technicians who manage our radio spectrum every single day.
Okay, so you're out there. A system is down. The big question, the one you have to answer right away, is always the same. Are we looking at deliberate jamming, a piece of equipment that's just given up the ghost, or some other kind of random interference? How you answer that question really determines your entire next move.
So let's start right there, with that initial assessment. At a high level, how do you even begin to tell the difference between a targeted attack and just, well, a normal everyday problem?
Well, the secret is really understanding the unique footprint of a jamming event. I mean, think about it. A jammer's effects pop up out of nowhere. They're sudden. They're usually confined to a very specific area. And maybe most tellingly, they often knock out multiple devices all at the same time. That is a world away from the slow, gradual decay of equipment failure or a massive network outage that affects everyone, or, a giant storm system. To go from just a hunch to actually confirming what's going on, you absolutely need a solid process. Out in the field, just guessing costs you time and it costs you money. So the source material we're using lays out this really methodical framework that helps you get to the right answer every single time. And here it is, that 4-step diagnostic approach. It's pretty straightforward. First, you confirm the real-world operational impact. Second, you actually analyze the spectrum itself. Third, you create a detailed profile of that suspicious signal. And finally, you systematically rule out every other possibility. So let's dig into that first step.
Step 1 is basically pure detective work. You have got to document everything. Which specific systems went down? What was the exact time it happened? And can you draw a clear boundary, a line on a map around the affected area? The whole goal here is to establish that critical combination of simultaneity and locality. Did a bunch of independent devices in the same small area fail at the exact same moment? If so, that is your first huge red flag.
Okay, next up you get technical. You whip out your spectrum analyzer and you start looking at the radio environment itself. Is the noise floor way higher than what's normal for this specific location? Are there weird new carrier signals that just shouldn't be there? Or are you seeing some kind of odd patterns, like a signal that's sweeping across a range of frequencies?
And this right here, this gets to maybe the single most important part of spectrum analysis. You cannot spot an anomaly if you don't know what normal looks like in the first place. Having that baseline data for your environment is absolutely 100% non-negotiable if you want to be an effective interference hunter.
All right, so you've found an anomalous signal. Step 3 is all about putting that signal under the microscope. What are its characteristics? How wide is it? What kind of modulation is it using, if any at all? How powerful is it? Is it on the time, or is it pulsing on and off? This is where you build a detailed profile of your suspect and start comparing it against the known signatures of jamming devices.
And the final step is the process of elimination. Before you cry jammer, you have to be absolutely sure it's not something else. Was there a big solar flare or a major thunderstorm that day? Go check the equipment logs. Did a power amplifier just happen to fail? Is there a known network-wide outage? If you've eliminated all of these other possibilities and your evidence still points to a localized, persistent signal, well, you're getting very, very close to your answer.
So now that we have the process down, what are the actual clues? What are those telltale signatures on your spectrum analyzer that practically scream jamming?
These are the classics, the ones you really look for. You might see the entire noise floor just rise up like a tidal wave of noise. That's a brute force attack. Or you could see a single, powerful, unmodulated carrier signal just parked right on top of the frequency you care about. Other jammers use a sweeping signal that moves super fast across a band, or you might see these structured, repeating pulses that are specifically designed to mess with digital communications.
Now, sometimes just identifying the type of signal isn't enough. To build a truly conclusive case, especially if you're thinking about legal action, we can actually adapt some techniques from the world of signals intelligence, or SIGINT.
This is all about building an absolutely airtight case. For instance, you can use geolocation, taking signal strength readings from different spots to triangulate the source. You can correlate the timing of the jamming with other data, like checking security footage to see if the interference starts exactly when a certain vehicle pulls up. You can even fingerprint the signal, creating a unique signature for that specific device.
So when you put it all together, a true jamming event becomes pretty unmistakable. It's not just random noise. It has 4 very distinct characteristics. It starts suddenly, it's confined to a specific area, it affects multiple devices at once, and the signal itself has a structure that's clearly designed for one purpose, and that's disruption.
So you've done it. You've followed the steps, you've analyzed the signal, and you've ruled out all the alternatives. You are confident you are dealing with an intentional jammer. But that leads to the next critical question, and it's going to be the subject of our next tutorial. You've identified it. Now, how do you find the source?